evaluate the limit as n tends to infinity of 3n squared minus n over 1 plus 2n squared. So we're going to evaluate this limit in two different ways, using two different techniques. The first one will be to divide the top and the bottom by the highest degree term, specifically the variable with the highest degree. So that's going to look as follows. So the limit as n tends to infinity of 3n squared minus n over 1 plus 2n squared. And then we're going to divide the numerator by, so the highest degree here will be n squared over n squared. So this can be rewritten as follows. So in the numerator, we have each term is going to be divided by n squared. So 3n squared over n squared minus n over n squared. Same thing in the denominator. And plus 2n squared over n squared. And now we can see that some of these terms will cancel. For example, this n squared cancels against this one. This n cancels against one of the n's in the denominator, and this n squared cancels against this n squared. So now we can rewrite this and see what we have left. In the numerator, we have a 3 minus 1 over n. In the denominator, we have 1 over n squared plus 2. So at this point, as n tends to infinity, we're simply going to substitute in infinity anywhere we see n. So this can be then written as 3 minus 1 over infinity over 1 over infinity squared plus 2. Any quotient divided by infinity will be going towards 0. So this means that the following two quotients are, for all practical purposes, they equal to 0. So we can now rewrite this as 3 minus 0 over 0 plus 2, which equals the limit of 3 over 2. So that is one method. This is a bit longer, this method. The second method I'm going to show is to eliminate any power of lower degree. Okay, and it's quicker usually. So method 2, we start with the limit as n tends to infinity of 3n squared over n over 1 plus 2n squared. So what we're doing here is we're simply eliminating any terms that have a lower degree than the highest degree. The highest degree here is 2n squared, right? Why can we do this? Well, as n approaches infinity, this term here, for example, minus n, is going to be much, much smaller than the 3n squared. As a matter of fact, it'll be neglectable, so that's why we can eliminate it. Same thing over here. 1 plus this second term, well, as n squared tends to infinity, infinity squared actually, the 1 plus this term is simply going to be insignificant. That's why we can eliminate them. So if we do this, we can now rewrite this with the remaining terms, which are going to be 3n squared over 2n squared. And now we can see that the n squared terms, the n squared factors just cancel each other out, which means that we're just left with 3 over 2. Obviously the same limit that we got using our first method.